Hi, Mohan.
Hi. Hi. Good morning. Sorry, good evening.
Good morning. You are in India or outside?
At on-site.
Okay. How are things going?
Good.
Which company you are working in?
I works for Fox.
Cool. Hi, Karuna.
Hi Rahul.
I'll wait for 1 minute. We'll start then. Okay, we'll start. So till now, any questions or any concerns you want to ask something? No? Okay. So let us move further. Yesterday we were discussing about throughput, about the production logs, how we can do workload modeling, how we can uh, come out of the number that we need to load test with, right? So if you have production logs with you, there is no substitute of that, right? Nothing better than having a real logs with you and then coming out of the load numbers. And today we will discuss about how you will decide what user load you want to achieve if you know the throughput. Now, in this case, you are aware you need to hit, let's say, 3000 hits in 1 hour, right? Now, how to conclude how many numbers are needed? Okay, I hope you must have heard of Little's law. Anyone want to add? Anyone want to tell what is Little's law? Oh, sorry.
Little's law as explained yesterday actually. Little's law is number of user will be equals to throughput times the response time uh, with addition to uh, pacing and think time.
Yeah,
You need to
so
add think time as well. Yeah.
yeah, so that will be your Little's law, right?
Yes.
Now,
Concurrent user, number
uh,
of concurrent user. Okay.
number of concurrent users. Yeah. Okay. Now let's say business says you want to hit let's say 3000 hits in 1 hour. So while you calculate in TPS, that will comes out to be divided by 3600, correct? And let's say response time of each flow is taking 10 seconds, and pacing and think time both you can calculate, right? Are you with me?
Yes, yes.
Yeah. Now there are two things. Okay. Let's say you want to achieve 3000 hits in 1 hour. Okay. One way is giving these two numbers less. Okay. So if you give less wait time, you need to increase the users, right? If you give more wait time, you can frequently hit your application and you will still achieve that much of TPS. Are you with me?
Yes, yes, true. Yeah.
Yeah. Now, can anyone tell me? Now you have two variables here. Okay. The wait time. These two I am considering as one. Okay. The wait time plus think time and the users. Okay. You are only aware
Can you
about.
come once again? Can you start the TPS?
Okay. Fine. So we were discussing about Little's law. Little's law says concurrent users are equal to TPS multiply by total time. Total
Okay.
time means the response time taken by the flow plus your pacing. Pacing means the time duration between two iterations, and think time. Think time means, let's say in your flow, if you have 10 transactions, so each there will be some delay between each transaction, right?
Is
To
time is the
simulate the
execution time? Time is the total execution time or request executed time? TPS into time.
this this
Top
yeah,
one. TPS into time. Hmm.
this is equal to your execution time plus the wait time you need to introduce so that you will achieve this much of TPS. Okay. Okay. I'll let me give you one example. Let
What
me
is
open this.
pacing?
Okay. So the pacing is, suppose you are doing one flow, let's say buying some item from Flipkart or Amazon. So the flow is you log in, you search the product, add into a cart, do the payment, then move out, right?
Yeah.
So user has to iterate this flow again and again to simulate that load. Pacing is once the user finishes first iteration, once it is done with the payment, then there will be some delay before starting the next iteration. So that is pacing. Pacing is equal to delay between two iterations. Okay.
I mean,
And
two
think time,
transaction basically.
no, transaction is okay. Now when you say transaction, if you mean by whole flow, then it is yes. But if you say transaction by one API or one page, then that is not true. Okay. Let me
Okay.
come to the Jmeter. I'll tell you.
Suppose login is one iteration, login is one transaction I am considering. Then add to cart one transaction.
Yes. So then delay is think time. Okay. Now in this case, where is my another Jmeter? Okay. Let's say I have these three different transactions, but these are all part of one flow. Let's say this is the login, this is adding into cart, this is
Okay.
payment. Okay.
Okay.
So think time is you are adding some delay here. Okay. You are adding some delay in between
Okay.
these two transactions. That is think time. Okay.
Okay.
Pacing is the timing that you are inserting after once this whole three APIs are done with their functionality, with their operation, you are adding some delay, that is pacing.
Okay. Delay between iteration pacing.
Okay.
Okay.
Yeah.
So how do we find that value?
Yeah. How do we find that value? Now, if you are aware, what user load you want to achieve and what throughput you want to achieve, then it is very straightforward. Okay, like in this case, it's a simple maths equation. If you are aware, if your business says, I want to achieve this much of transactions in 1 hour by using 100 users, okay, then it is very straightforward. You will just and this response time you can calculate by hitting your by running Jmeter only once. It is like a hit and trial. Okay, run your all these three APIs once. You can do this multiple times to get the averages. So if you run all these APIs, let's say it is taking somewhere between 3 to 5 seconds. So then you can consider, okay, the response time is 4 seconds. Okay, so your response time become 4 seconds, and business says you want to achieve 300 transactions using 100 users. Then using this uh, function, you can directly calculate your pacing. Need not to calculate think time, that we will come later, but it will give you pacing. Now, how much pacing it will become? Anyone good in maths?
Okay.
Okay, so it will become 3, 6. Where is the calculator?
Plus, 3 minus 4.
3600.
116.
Okay, so should I trust you?
Let's do.
Okay, that's right, bro. 116, right? So that means I need to complete one iteration in 116 seconds. Okay, I need to complete one iteration in 116 seconds if I want to achieve this much of throughput in with these many users. Okay, so now let's say in your flow there are three transactions, so you can insert two think times, right? And the rest of the amount will be your pacing. Inserting think time, when you are about to insert think time, just uh, think from a user perspective, from an end user perspective, and from application perspective. Okay, let's say if it is a banking application, then how the user behaves. If it is some commercial app like e-commerce, how the user behaves, how much time it stays on one page before moving to another page. Okay, generally, let's say you put 5 seconds of think time, and if there are three transactions, let in this case, like, right, so you can put 5 seconds here, 5 seconds in between here. So 10 seconds are gone. So 106 minus 10, 100 and sorry, 116 minus 10, your 106 seconds. So that will be become your pacing. Now you need to make sure that you will iterate your one flow with single user in such a way that it will take 106 seconds, so that if you run it with 100 user, you will be able to achieve this much of throughput. Are you with me? Any confusion? Please do not shy. Ask me questions.
So
Yeah, but even
106 second for that, suppose three transactions. So
Mhm.
how will we decide that time taken, users, number of users? We will give number of users 100. Then number of
Correct.
iterations per transaction we need to find, right?
Yes.
So how will we find that?
Can you come again? You are saying users you have. What was your next point?
Yeah, for whole flow, 116
Mhm.
is the time taken.
Yes.
Yeah, then we minus that think time. Suppose if there are three transactions, then we minus for two minus 10. Now the time taken is 106 for three transactions to complete.
Time taken is still 116 only. Okay, so pacing is still 116. Why I am already excluded this 10? Because I am giving two times think times, right?
Yeah, think time.
There are
So 106 is basically the time response time of three transactions. T1, T2,
not the response
T3.
time.
Then
Not the response time. You need to execute in such a way so that
yeah,
there
total
must be
response
some
time.
delay. So response time will remain this. If you are understanding it in that way, I do not know, but don't call it as a response time. Response time will remain 4, but you are actually making the thread sleep. You are making your user sleep for some time. Okay, you are making your user sleep for some time so that it will wait. It will wait for this much time to start the next flow.
Okay.
So, so what you are saying is 4 second is taken by each transaction, right? Each API. So 12 second
I am
is for
yeah,
three, right?
I am
12
considering
second
4
for
seconds for all the three here.
for
These
all the
three,
three.
yeah, yeah. Because I am considering this as my one iteration. Okay.
So response time 4 is for all three, not
Yes.
individual one.
No, not individual one. So you just check it by running your test with single user, single iteration. Just run it for 3 to 4 times, and you see the average somewhere lies between 4, right? So it can be any number. I'm just taking an example. And then business says you want to hit 3000 times with 100 users, okay, in 1 hour. So this will be your calculation. So you need to make sure your user will execute each flow, each iteration in such a way it should consume this much of time. Okay, it should consume. Now, how will you make that? You can use either create your own scripts, or it's better to use your these timers. Okay, so directly you can use Jmeter timers and make the user wait for this much of time before starting the next iteration. Why it is
So
important? Yeah, go ahead.
yes, so at the last of these three transactions, right? We have to mention 116 somewhere, like just
Correct.
like tick time, right? So that the test completes in within that time. So that's what you're saying, right?
Yes, that's right.
Oh,
Yes,
okay.
Means one iteration, the time difference between first and second iteration is 106 seconds.
correct. Correct.
Okay.
Yes.
Vicky, this phrase response time seems to be confusing. So I think instead of that, writing something like one user, one iteration time, that could make more sense. So we are running that one user without pacing, without think time for one iteration, uh,
Fine.
and record that time, and then use that in the formula, correct?
Yes.
So we are summing up on all the response time or taking average of
Now
each
it
transaction. Taking
you
average
can
of all the transactions.
you can sum up all. See, when you run test, right, you will get if you are running these three APIs in a transaction controller. Okay, let's say I am using this transaction controller here and I am running this test. In your report, you will see the response time for this transaction controller,
Okay.
right? Or you want to check. I mean, you are familiar with JMeter, right? JMeter testing and all.
Jmeter, I am not familiar. I worked on K6, so but I
Okay.
am learning Jmeter also.
Okay, no worries. I need to run this app. You need to wait then for few minutes.
Okay, it's fail also, no issue. Just to add the think time and run it. We are not validating. We want only the response time, no? Total
Cool,
execution
cool.
time we
That is
require.
also
Total execution
yes.
time is
So
required.
if
Mm.
yes, so if you run this,
I think when you run it, you need to disable those timers, right, Vicky? You can't have those timers, like think times between the transactions when you're calculating
yeah,
one user,
if
one
you
iteration
want,
time.
yes, if you want to see that, yeah, if you want to see that. Anyways, if you are in your transaction controller, if you have unchecked this, it will not include the timing for this timer.
Hmm.
Okay. So here, let's say now, in millisecond, right? Just suppose it, consider it as seconds. Okay. So let's say this is 4 seconds, right? 4 seconds is for your this transaction controller. Okay. So that means you can run it for 3 to 4 times and just see the range, okay, where it is varying. Then you can take that as, like Raj mentioned, the time for single user, single iteration. Okay. Then put that time in this formula. Okay. And then calculate your pacing and think time. Now, think times will be varying because if your flow is having 20 transactions, 30 transactions, obviously you will insert more think times, and finally your pacing will get reduced. Because if you are inserting 10 think time or 5 second each, then 50 second will be deducted from here. Ultimately, the end goal is you want to execute your flow within this stipulated time. That is the end goal. Okay. Any question?
But what if think times between think time between two transactions is different? Like in real time, launch to
Mhm.
log in to add to cart, the amount of time the user spends between these two even
That
activities, it varies. So how, like when
yes.
we use this
See.
formula, when we put think time there, so
Hmm.
are we averaging all those
See.
transactions, all those think times?
Now it depends, right? What you are want to achieve. Now here, when I say TPS or the throughput, by throughput I mean how many time I want to iterate the whole flow. Now it depends upon business requirement, right? So let's say if they just want to check a single click, okay, then throughput will be hitting only one transaction, right? There will be no think time. All the time will be your pacing because there will be single transaction. And if you're getting my point, right? So it depends. If yes, that is true. If there is different login, different operations, then logout, and each transaction has different response time, that is fine. But when we say throughput, what we want to say is the final, suppose between login and logout, whatever operations you are doing, right? So that complete flow is called a throughput. Okay. Whether you are buying the product, okay, so business will comes, right? Okay, we sell these many products in 1 hour, and this is our throughput. Now that sales means total hits throughout the flow. The customer is searching the product, uh, adding into the cart, doing the payment, right? That is one flow. Now when you're getting my point, right? So
Yeah.
if
See,
yeah, so
for web service, it's straightforward. There's no think time involved there. If it's a single web service, if the transaction per second is
mhm,
defined, like I need 2000 hits per, like 1000, whatever, that is,
mhm,
they define that, then we can find the concurrent users, response time for one iteration, that's straightforward. Pacing is what we calculate and we include and we
mhm.
run. There's no think time there. The confusion is only when we are running, when we are doing this for UI workflows, where we have this launch login, do something, log out, and all. That's when this whole thing is getting a little confusing. Um,
Yeah,
mm,
so that's what I mean. You need to understand, like, whatever business gives you, sorry, whatever business gives you, whether those values are related to single transaction or whether those values are related to your complete flow. Somewhere, I mean, sometimes those values are related to the last button. For example, it's
mhm,
about filing a claim. Okay, the customer go inside an application. Let's say you are logging in Policy Bazaar, searching the product, then buying a policy, right? So the customer is buying the policy at the final page. Okay. So whatever
mhm.
steps you are doing to reach that final page, okay, that the whole uh, the whole flow will become your one iteration, correct? So because you have to reach to buy something, you have to complete a certain journey. So to complete that journey, you will consider the whole process as a one flow, one iteration.
हाँ
Okay.
एक मीटिंग में हूँ आ रहा हूँ ताए
Yeah, but that is true. I mean, it's straightforward for APIs, web services, but in UI cases, it is somewhat complicated. But we need to understand what we want to achieve. The end goal that has to be keeping in our mind, right?
Okay, I
No,
mean,
the
in
only
the
the
real
thing
time.
is, even if we implement the little's law, the actual behavior will be plus or minus only. We can't get the exact on dot figures. It purely depends on the way the system behaves and the way the script has been designed. If the script is when we come to the actual project execution, the client may come up with one transaction or two, or he may come up with a list of transaction. The way we design, the way the way effectively we design the scenarios, we'll get the nearby values. We can't stick to
That
the
is
norm.
right.
That's why
Yeah,
we will give plus or minus.
that is correct. That's what I was using one term, extrapolatory numbers, right? Yesterday. So that is true. I am completely agree, and that will remain there in performance testing because there are so many different things. We are using tools, right? And like we mentioned, we are not including browser rendering. So whatever we are reporting, that will be plus or minus only. But
Most of the
again,
process
we
we
should keep.
follows nowadays, like everyone is saying little loss, but in real practically, no one will follows the little loss. Just they will execute with single execution and extract the based on that time. They will take the response time based on that calculation, because see, most of the time they will do in the lower environment. They will take that value, but execute the test in another different upgraded environment where there is a response time will varies. That's why the most of the time we prefers to get from the actual load test environment, run with the single and calculate. We'll do be doing the calculation of a trial and error method, and will wherever they want to, they give the restriction saying that if we want to restrict the TPS, based on the TPS we will adjust the think times and pacing times, and we'll run it.
Yeah. Yeah, so I mean, you are right. I have also noticed this, but I mean, I have noticed, I mean, other part of the story as well. In my recent projects, what I have felt, there are very clear requirements given by business. Even if a journey has 10 different transactions, I mean, I have experienced that in recent times only, okay, in last 2 to 3 years. Uh, they have provided response time, they have provided throughput each for each and every transaction. So I mean that becomes very easy for us as well. But you are right, it happens, and there are many chances, like you are running tests on lower environment and production is far better than it. So whenever you report your result, okay, they'll just, it's nice to have thing. Okay, you reported 4 seconds, but we are expecting 2 seconds, so we will get 2 seconds because our production is having more capacity, right? So that thing will happen. But still, I mean, like I mentioned yesterday, uh, how much value we can add from our work, okay, that we need to always consider. And it's all about how we sell ourselves. It's not only about sharing the results, it's all about giving them some value, okay, right? Because see, I mean, these things have been discussed again and again. Cloud is there, scaling up, scaling down can happen anytime, just on the fly. But why we still need performance testing, okay? So yes, things are there, but you may get certain projects wherein these things become very critical, become very important. So that's why I'm covering it. So another point I want to discuss. Now let's say you are achieving 3,000 transactions using 100 users here. Okay. Now there may be instance, may be some situations like this. Business is not aware about this value as well. Okay, they are only aware about, okay, we want to achieve 3,000. Let's say they are saying there are being 3,000 policies or 3,000 claims being filed in 1 hour. That's what we all are aware of. Okay, rest all you need to figure out how you will achieve that. Okay, now what will be your thoughts on it? Because see, again, it again comes out to be, you can say it's just a matter of giving some number and let's say you want to achieve it with 200 user. Your pacing will be reduced, right? So it will be what? Anybody good in maths again? Who was that guy? Silent? Don't be silent, brothers.
You can multiply that
By 2.
transactions per second into the response time. So that way you'll be able to get the concurrent users you need.
I can calculate. Sorry, I can.
The transaction TPS multiplied by the response time, we can get the concurrent users from that. Users equals, say for example, TPS target is 100, and then you multiply that with the response time of that API. So you will get the number of users what you need, the concurrent users what you need.
Yeah, so yes, that is true. Now my question, my point is, let's say now there may be 2 different cases here. In one case, see, to get the users, you also need pacing time, right?
Yeah.
Right?
Correct.
So response, if in this equation, there are 3 different variables. So I am still considering these 2 as one. So there are 2 different variables, response time plus your wait time. So let's consider these 2 as wait time, right? So you are only aware about response time. You are not aware about this, right?
Okay.
So what I'm saying is, let's say business do not gives you this number. Okay, they don't know how many users you can test with. They only know they want to achieve these many of transactions in 1 hour. Okay, so in first case, what we have done, this 100 second of pacing, it comes out with 100 users. Okay, and now 240 second of pacing, 240 second minus 4, so that will comes out to be 236, right? So this 4, I'm subtracting it, 236 seconds of pacing, it is coming up with 200 users. So that means if I run my test with 200 users, I need to implement more wait time. If I run test with 100 users, I can achieve the same TPH with less wait time. Now you are getting the 2 different scenarios, and business is not aware how much user you can test with. Business is only aware these many transactions they want to achieve. Are you with me all, or shall I explain this again?
I'm confused how the
Okay,
pacing is
let me.
more here. It
Yeah,
should come this, right?
See, if you are hitting an application with more user, right? So there will be more wait time. Okay, so it means the work will get complete in lesser duration. Correct. So it's a simple. If 10 people are working on same task, and if 20 people are working on same task, 20 people can achieve that quickly, right? But I do not want to achieve that quickly. I still want my TPS to be remain the same. That is why my wait will get increased. This is wait time, correct? This is wait time. I need to wait for this much time, right? Are you with me now? So if the same task is being done by 20 people and 10 people, 20 people will do it quickly, but I don't want them to do it quickly. So I will introduce some wait. Okay, I will introduce some sleep time so that the ultimate goal will remain the same. I want 10 people and 20 people, both of them should complete in 1 hour. I don't want, if 10 are completing in 1 hour, 20 should also complete in 1 hour. 20 should also complete in 30 minutes. No, I don't want that. I want 20 should also complete in 1 hour. Okay. So that is why my wait time will get
increase your pacing and think time. That's all, no?
Yes, that's all. I mean, you can increase the pacing, but now my point is, now which scenario will you consider to test? If you do not aware how much user you want to test with, you are only aware how much TPS you want to achieve. Out of these two scenario, which one you will consider for load test?
With 100 users.
Okay. And any justification of
Because
that?
it will be completed with much faster. Like we will save time.
Your test will run for 1 hour, bro. Yeah,
In
same.
both
Yeah, I got you. I got your
cases,
feelings. I got your feelings.
in both cases, the test duration is the same, right?
Yeah, yeah.
So
Test
how
duration,
do we
yes,
pick
yes, yes.
between
Test
100
duration
and
is
200? That's what the question, I guess. I mean, if there is a lot of test data, I mean, if I have to create 100 user IDs, 200 user IDs, and achieve the same throughput, I think I would go for 100 users,
okay.
because I only
I
need to
want
create
answers
100
from
test
others
user
as
IDs.
well. Please engage yourself.
Starting with 100 makes sense because from the lowest is what we have to start and increase further.
Mhm. Okay.
If it is working with 100, and then move ahead with 150 and 200 like that.
Mhm. Okay. Again, I mean, there will never be any right or wrong here, right? Okay. Yes, 100 will be better in those cases where our, goal is to hit the system frequently. Okay. And where the goal is to sit for some idle time, then 200 user can be that case. But most of the time, yes, this will be a better place because you are hitting system frequently. Okay. In this case, your sessions remain active, remain idle for longer duration. Okay. So, I mean, that was one thing I want to share with you. Any question, any thoughts from anyone?
The other thing could be resource utilization also, right? Like if 200 users, how the CPU, memory, and other things are utilized compared to 100 users, there could be a difference, correct?
Yes, there will be increase in the response time, resource utilization, everywhere there will be increase. But even though increase, it will reach the
Throughput.
expected expectation of a user.
Uh, I would say if you see there will be not that much increase unless or until idle sessions will make any difference to the application. In this case, a user is waiting for around 3 minutes to complete one iteration. Okay. And in this case, a user is doing that in less than 2 minutes. Okay. So again, there is no right or wrong, but I got your point. What you want to say, the resource utilization will be more because users are more. That will be there, but you also need to consider users are just sitting idle for so much of time. They are actually not doing any operations on the application. They have created a session. That's it. Okay. But in this case, they are keep on hitting frequently more than in from this case.
I mean, the amount of time a user has to wait when it's 200 users for its turn is maybe a little more than how the amount of time it has to wait when it is a 100 user situation, correct? Like they may be waiting in the queue for their turn. I mean,
Uh,
at the end of the day, this comes down to the number of threads we configured on our application server. Say if a number of threads is
mhm,
something we configured as 100
mhm,
or 150, when you run the test with 100 users, the results of that in comparison to when you run the test with 200 users, would there be a difference?
mhm.
Because in terms of transaction response time, because there's some wait time that is introduced because of excess number of users. Am I making sense?
Yes, I am getting your point. Uh,
Because this wait time for the user's turn to run, I
but
mean, whatever it is. Yeah.
hmm. So
It
yeah,
kind of
that
gets
is
added to the
there.
transaction response time, right? That's what I'm trying to say. If it has to, the user has to wait in the queue for its turn.
No, wait time will never add to the transaction response time. No. Wait time will be isolated from the response time. Whenever we report response time from
No, no. Think time and pacing, these two are different. But wait time, when I say that processing time of that particular
Mhm,
transfer, add to card when 100 users are
mhm,
running, the amount of
What
time.
Vicky is trying
mhm.
to say here is, I think the weight is saying it is on the Jmeter side, the think time and the pacing only, not the weight on the application server. Finally, what I understand is with 100 users or with the 200 users, the utilization should remain the same. With 100 users, the hits are happening so frequently, but with 200 users, the hits are happening, but there is a certain amount of think time and the pacing more compared with 100 users.
Yeah.
The point which I'm trying to say is like, say, for example, Amazon, when 100 users are on the website, how fast the page is loading. When 1,000 users are on the website, how fast it is loading. We could see the difference, right?
That's a UI level, whereas Jmeter is only done at the server level. Server won't work on the UI perspective. You are speaking about the performance of an UI, but here the calculations are performance of a server.
Yeah.
Yeah, but I mean, every point is valid here. It's like I mentioned, there is nothing right or wrong. Again, it depends upon, like Raj has mentioned, it also depends upon how many threads we have configured and all those things. If there are certain limit, you cannot make 200 actions, then ultimately you won't be able to achieve that with 200 users. But the point I want to make is what we want to achieve, that should be keep in our mind. Okay, sometimes we are just testing the APIs, wherein the end goal is to just the TPH or the TPS. Okay, irrespective of what you how much load you are hitting it with. Okay, so again, whenever you are hitting with less user, it will hit more frequently. That will give you a good, performance metrics. And if your users remain sitting idle for longer duration, that may not give you the better performance metrics. Okay. Now let's move to anything anyone want to ask or okay, sorry.
Vicky, I heard you say TPH. If you're going with TPH, do we need to divide this whole thing by 3,600 or
Yes,
something? Okay.
correct. Yeah, that's what we have done here. Yes. Okay, so the next thing I am going to show you is we were discussing about pooling connections, right? Data
Yeah,
pool
before.
connections. Sorry, anyone saying
Yeah,
something?
so yeah, I have a question. So the same scenario we were discussing. So this is only for one scenario, or how is it? Suppose say if we have a multi-tier architecture, right? Very complex one. So how do we
Mhm.
do the
Yeah.
same exercise for that kind of system? And suppose if we have 30, 40 scenarios to simulate, right? So how do we do that in a complex architectured system?
The first question again, what business want to achieve?
Mhm.
Okay, what numbers they are providing you? Now that architecture belongs to what kind of application? Okay, sometimes the applications are employee facing. For example, some Finacle kind of product who are which is used by bank employees, right? Some
Mhm.
applications are
Mhm.
end consumer facing. Okay, and if something is end consumer facing, that kind of application require frequent hits because you are expecting that kind of load, right? So that, I mean, you need to keep these things in picture. I mean, two three simple things, what kind of application it is. The first and foremost, if the very I mean, there is, again, I would say, no substitute. If you would get these requirements from business, then your job is half done. right? If they will give you, this is my TPH and this is my user load, concurrent user load, then your job is half done. And if they say, okay, I don't know, I have the TPH, you do everything you want, then you need to do this exercise. Okay, then do not go with more users. That will not be the ideal case. Go with less user so that your application remain busy. Okay, your hits remain frequent. Okay, so that will also be a valid test. Okay, so I would prefer by going with this. If you are not aware, if your business is not aware of anything, I would prefer going with this scenario by hitting my application more frequently rather than going by this where my users are sitting idle. Making sense?
Adding to it, in general, we used to come, the client, when we work for the product base, we used to come up with this scenario. The user will come up with a 30, 40 scenarios. But at the time, we will collect the total user load and we will ask them prioritize the 30. What will be the
Mm.
highest in this transaction list? What is the highest utilization of transaction? Based on, and we'll give the priority of that and segregate the user load across all the transaction, and we'll do the normal calculation, and we'll segregate considering as a total transaction as an 100%, and we'll segregate each transaction based on the priority. We'll calculate the percentage, and we'll assign that a percentage of load distribution, and we'll assign the total user load to the thread group based on the percentage allocation. Jmeter will take care and execute.
Yeah. Okay, so let me quickly jump to another thing today. Uh, I think so. Like we were discussing about three-tier architecture. Okay, I have one sample application with me now. Uh, so this thing I have discussed yesterday while showing you the prod logs. Nginx. Nginx is your web server. It can act as a load balancer as well. And then your app server and then database server. So what I am doing is I am implementing all these three different things on Docker. Okay, so what we will experiment here, we will try to play around with uh, thread pool connections. Okay, and see by increasing the load, okay, how the connections will impact your response times. Okay, are you with me? So just to give you a brief overview about this, this is basically a config file. Okay, so app server can scale up or scale down. Okay, and then we have, oh, sorry, web server. Then we have app server. So in app server, we are using one program, which is a payment uh, query. Okay, so we are using one database query here, like this. Okay, we are fetching the ID, amount, and status from one API. Okay, and how we are connecting that database? We have used PostgreSQL on Docker itself. So this is how we have created three entries inside database. Okay. So
Where
if I
the
run
thread
this,
connections, this thing had been defined.
okay. Yeah, thread connections are defined here in app server resources.
What kind of app server is this, Vicky?
Tomcat.
Thank you. Okay.
So you can see here, I have given 50 max threads. Okay, let me increase this Hikari pool size also to 20. Okay, this you can set it as per your requirement. In application, if you see connection timeouts, right? So all these settings are kind of these settings. If your query is not returning anything within this much time, you will get connection timeout. Okay. So these connections define how much application server and database server can interact with a maximum 20. minimum 5 idle. And these threads, we are making sure like how many user that you are uh, putting load on web server, this thread will impact that. Okay, this value. Now what I will do, I will
1 minute.
simply
1 minute.
What is minimum speed? Okay, go ahead.
Correct me if I am wrong. This
yes, please.
data source maximum pool size is DB connection pool. Is it a DB connection pool?
Yes, this is a DB connection pool. Yes.
What about these threads? Max threads of 50.
These are your related to web server. I mean the front end threads. These are your backend.
Web
Okay.
server. That means both will be configured in the same web and database will be configured in the same configuration file.
Yes.
It's an it's an application or a web server?
It's an application server settings.
Application server. Okay.
Yeah. The web server was this was Nginx config. This was web server. Okay.
Here there won't be any connection pool.
Here there are settings related to your scaling up of instances. If that we can do, we'll do step by step. Here what can happen, these Nginx can auto scale itself from one to more instance. Okay, if you want to scale it up, that will again, I mean the ultimate goal is to handle more load. Okay, so increasing the instance means you are balancing your load across not only one machine now, but across 3 different machines.
Where it is listed, max count of instances? Number.
That we
there
can,
should be some
yeah,
limit.
it is not, yeah,
So
it is
load
not listed here.
balancer doesn't basically we have instances of app server, not load balancer. There is only one load balancer.
Yeah, but what I'm saying, if you want to increase the instance of server app here, okay,
App
your web
server,
server
okay.
here, web server here, you can do that.
Web or app
Those
server?
setting web server, those
Web
are,
server is this only. Web server and load balancer are same, right? Here.
yeah, this is your web server.
Nginx is
has
our
a
web server and load balancer both.
Yes, it can acting as both.
Okay.
I mean, in
It
our
can,
architecture, is Nginx web server, or is it being used as a web server or purely as a load balancer?
it's
Right now,
it
in
is
the
a
application which you're showing us.
web server.
So so there's a load balancer, which is Nginx. Web server is also Nginx. App server is
Yes,
Tomcat.
current
Database is Postgres.
yes.
Right?
Currently, this Nginx is being used as web server. It can also be used as load balancer. Currently, it is using as, okay, don't get confused. Currently, it is using as web server. Forget load balancer. Okay.
So there is no load balancer in our current architecture.
No,
Okay.
that's right.
So the request will be hitting the web server, right? And the request will be forwarded by the web server to the application server, correct?
Yeah, correct. So request will be hitting the web server. It will be forwarded to the application server. Whatever the logic is there inside application server, that operation you can see on your UI or on your Jmeter request. Okay.
In that case, why are we configuring threads on the application server instead of web server? Because that's the client, the user facing, that's where the requests go first, right?
No, that Apache Tomcat configurations, whatever you saw, that max threads, right? So the Apache Tomcat will allow maximum of 50 or so, whatever is configured requests, maximum. If you go to that the file, right, the YAML file. So if you see this, where is that? Maximum threads. If you see that, right, line number 8. So Tomcat will allow only at max 50 concurrent requests. It won't allow anything beyond
web server.
Correct, from the web server.
And the same like 20 DB connection, it can make up to 20 DB connection with the DB server.
Correct. Yes. If there is a 21st or that is looking for a connection on the TP, that will have to wait for one of the connections to be released.
Yeah, for the like.
Isn't something like that also applicable to the web server? Like web server can only allow these many users requests, and then it'll forward the request to the application server and so on. I'm just curious, is this whole thread and database and the connection pool, is it only applicable to app server?
In this example,
And
whatever Vicky is trying to showcase is using a web server only to redirect that request to a application server.
application server.
Yeah.
Okay.
Okay.
So
Okay.
redirection doesn't take time. So there is no need
Mhm.
if there are 10 threads also. They
Okay, even if
will
it's like
work very,
1,000
yeah.
users or million users or 10 users, it doesn't make a difference. All it is doing is to forward the request to the
Yeah, yeah. So that's
application servers behind the web server. Correct.
so we do
Okay.
scaling of app server generally, not web server.
Mhm. But in some situations, web servers are used to serve the static content, right? Like not everything will be present on application server, but
Static
HTML,
content
CSS,
are
JS, yeah.
so static content is present in CDN. So it's not coming from web server also. So nearby
Mm.
CDN is serving that static content.
Okay. Okay. So then that's a totally different story. Okay.
Yeah.
All right. Yeah. What is this minimum spare threads equal to 10 then? I'm just here
Anyone
under
want
max
to?
threads 50. I see a minimum spare threads 10. What is that? What is that, Vicky?
What is spare threads? Are they different from?
Mm.
Anyone want to say on this?
I don't know if I'm getting. I mean, I maybe it's like 10 threads are available at any time,
Mhm.
and others come into play
Spare, I
based on
think
the
extra kind of.
Yes, spare, like, I mean, as this name suggests, they will remain available for any sudden spike. Okay, so that means 40 will be utilized unless until there will be some sudden requirement. So don't get much confused about this number. Maximum will be 50. Okay, so that is it.
Okay.
And where do we have connection detail in web server, which is connecting to app server?
Yeah, all those settings are being done through Docker. Okay, so we are using Docker file here. So why anybody want to add something on Docker? Why we use Docker? What is the use of Kubernetes, Docker, and all? In one line,
Docker.
if anyone can explain.
Yeah, so
Docker.
application needs environment basically. So I want to run on any environment and on any machine. So basically I will package my application in a container. So that container is lightweight also, unlike that virtual machine, and it can run on any platform.
Yeah. So
Uh,
basically, yes, that was the initial requirement of it because see, some developer is working on Linux, somebody is working on Mac, somebody is working on Windows. So we have heard this term again and again, right? Hey, this was working on my machine. Why it is not working on your laptop, right? So that's where Docker and Kubernetes kind of things comes into picture. So like you said, no platform dependency. Just create your own things and you can work on it. So this is the file where we are declaring everything, okay, related to your DB related to your app, related to your engines. Okay. Now, to start this, I'll quickly show. I have, okay. So this is Docker running on my machine currently. Okay, you need that to run this app. Okay, so this is the command to build up. So it will start pulling up all the dependencies, everything which is required to run this. We'll do one demo today, and the same thing we'll use, and we'll do one demo tomorrow. So what we are going to do, I have created one JMX for this. This is my JMX. Okay, so we'll run it with 200 threads for this time. Okay, so the first demo, what we will do is we'll run one test with that much of connections that I have shown you. Then what we will do, we will reduce the DB max connections, and we'll analyze how the response times varies. Okay. Yeah, so this is if it is started. Yeah, so everything is started now. Let me hit this on. Okay, localhost PID1. Okay, so this will be my response. PID1 equal to this, PID2 equal to this, PID3 equal to this, PID4 is giving me error. Any reason? Can anybody tell me why it is giving me error?
There were only
Data,
3 records in that
database has
database.
3 values.
Yeah, so that has 3 values.
But why it is showing white label error? White label error is different, no?
Actually, it is not there. That is why, I mean, database is there, but that entry is not there. So what I have done, I am just randomizing this request, generating any number from 1 to 3 and sending it with this API. So let it run for 210 iterations. Let me clear everything. Okay. Let us run one test. It will be very quick test actually. Yeah, it's done. Okay, so you can see here, average is this. So if you want to generate HTML report out of it, you can do that. I think it is a very quick test. You won't get much data points. HTML report. So meanwhile, what we will do, we will decrease those connections. Okay, so this is a very quick test actually. Okay. So let us make one change there and then we'll quickly test. So I will reduce it to, let's say, 5, and I'll save it. Now I need to restart my machine. I mean, restart the application. Okay, so it's better to, I mean, it's not required, but just for safer side, I'm deleting all those containers here. Is that file saved? Yeah, it is saved. And I think the test was very quick actually. We should run it for longer duration to have more data points, but let's see if it shows us some difference with 2000 bits. Now we are running it with 5 Hikari pools. Let us increase some threads. So anybody working on Docker cubes? Anyone?
Yes, some part of yeah, I work on Kubernetes. Some
Okay, yeah, K6 you said, right?
yeah. So
So,
basically, I run K6 via pod.
hmm, so you are um, on the fly increasing your load generators?
No, I need to give that view so that I define in a script.
Okay. Okay, so the app is seems to be ready now. Let me see once. Yep. Okay. Let us start the test. Okay, so if I generate an HTML report for this, Clarify 7. Okay, so the time is 1.3 now. It's almost double. Uh, right? So the time is double, although the users were 50% increase, the time got 100% increase. Okay, so that is how this connection pool can impact our response times. So the reason is very simple. Uh, your threads keep on their own wait state unless you process that query, right? So there will be bit of latency as compared to the lesser latency with more connections, right? All Anybody want to add something? Somebody's messaging.
Where can we monitor this connection pool utilization? Is there a tool where
Yes,
we can see how
yeah,
it is happening live?
we can do that everything using what I was showing you, JVisual VM and JConsole. You can do that. We'll cover that. I mean, tomorrow or day after tomorrow. Yeah. Yeah. So we'll also introduce some more complex application with some complex scripts as well. Okay. So the idea is to show you how these things impact, right? So whenever now it may happen if I increase more load, okay, and let's say there can be connection timeout error if my query is unable to respond within that particular time period, which we have configured here, right? Connection timeout is this much of 30 seconds. Okay. So if there is no response within 30 seconds, you will get connection timeout. Okay. So we can introduce those faults intentionally and can demonstrate that as well. Okay.
That is
I think,
database connection timeout error. Na? One
yes,
timeout
that
can be
is
from app side also, like
correct.
it's not responding to that API.
That is, yes, that is true. So I mean, the point I want to convey to you is how these things impact your latencies and eventually the response times. Okay. So whenever it may happen, there is no problem with your connection pool size. It may happen. There is problem with the SQLs running behind it. Currently, we are running it a simple SQL query, right? It's just fetching a record with our ID, right? If there are more complex queries, there may be possibility those are missing indexes or something. I mean, not written properly, not tuned properly. That will impact your query time, and ultimately your thread or your request from app to DB keep remain in the waiting state and finally timeout. So timeout not necessarily means your connection pool size limit has been exhausted or saturated. It may also be due to your query is not responding efficiently.
So that thread connection timeout is also specified in your YAML wiki. How long should the thread?
No,
Okay.
that is not there. Yeah,
What is this connection time?
we are only doing this.
Okay. So this is in milliseconds or?
Seconds. Yeah, this is in millisecond. This is in 30 seconds. Yes.
Okay. So you will eventually see connection exceptions because there are no, the thread has been waiting for a longer duration than that is configured. And on the UI, what do we see? We see 500 errors. Basically, if there's
Connection
a
timeout.
problem. Okay.
Maybe gateway
So,
timeout. We can
okay.
introduce that. Yeah.
Okay.
Okay. I think
So
we are
can
done
we,
for today.
from JVisual VM, can we actually see what is the state of this threads that are
Yes, we
waiting
can
in
do
the
that.
queue?
Yeah, we
Okay.
can do that. Yeah.
Okay.
We can configure that in JVisual VM or JConsole. I'll try to cover that as well.
Sure. That'll help
Yeah.
actually. Hmm?
Yes. Yeah.
Thank you so
Yeah,
much.
Dharmendra.
Yeah. So I think I may have missed what happened in the test. Like, why did the response time double or increase? Did we
Okay, let
change
me
anything?
share that. Yeah, we have introduced one change. We have increased this Hikari pool size from 20 to
Okay,
5.
from 20 to 5. Okay.
Okay. And we increased user by double. Okay. And we noticed the response time. No, users we have increased by 50%. I mean 200 to 300, but the response time got double. 100% increase in response time. So this was the response time with uh, lesser Hikari pool connections. Okay, 1.3 second, and zero point 0.6 second was with 20 pool connections. Okay.
Is there, sorry, okay, if we have addressed this one, now that we have limited this connection pool limit and we've tested this one, right?
Yeah.
Is there a calculation, some way to quantify where how many connections can your DB
Yeah.
allow?
What
So, because
anybody
I
want
cannot
to
do
add?
5,000 or 10,000, right? Just like that. So based on
Uh,
what parameters can we limit this connection pool?
Anybody want to say on this?
Infrastructure or I don't know.
See, yeah,
Not aware.
again, whatever I will say, that is based on my experience on live applications. What I have seen, the maximum connection limit set mostly in most of the cases is 10. Okay. I have never seen it more than 20, never.
But
This
in our
particular
applications,
TB,
we have configured it to, we have like 10 data sources. 5 of the major data sources we have configured it with 1250 connection pool maximum capacity that is available. Uh, because we run the test with the 200 users. There are a lot of
Mhm.
thread groups that are there. And we have seen the max connection pool reaching to 600, 700.
You
But
are talking
eventually,
about,
after when you log out, the connection keeps coming back to the pool. We monitored that. But I wanted to know how this is calculated. What is the maximum capacity of the connection pool that can go? How is there a database sizing that needs to be done? I'm not aware of this. You understood my question, right?
yeah, I understood your question. Um, I also need to check on this, how to get this number, but like I mentioned earlier, what I have experienced, are you talking about this Hikari maximum pool size?
No. Generally, any DB.
Okay,
Say we use
because this
Oracle,
is, yeah,
and
okay, this is something very recent and more efficient if you look at with some other technologies. So what I have noticed, the maximum pool size for this Hikari is being set to 10. Okay. And I that is my experience. I mean, in most of the cases, and if the and I have experienced connection pool timeout error as well. That is not due to because we have less connections, but because there were problem with the sequels. Yes, I do not know how to get that number which we need to set here. Okay, I
Mhm.
need to check on that. Yeah.
Okay, yeah.
So what I know, if I have to add, so it has to do something with the number of CPU cores. So based on that, it is decided what would be the maximum pool size, because database is deployed in some system, right? Maybe in cloud or somewhere. It has some CPU cores. So based on that, our number of threads, CPU threads, is what helps us decide the maximum pool size.
Yes,
I mean,
that
this is my knowledge. I'm not sure
no,
if it is correct or
no,
not.
that is valid. That is valid. See, compute power always comes into picture. So, what is the compute capacity we cannot ignore that. Yes, that is true.
But is that the only parameter? Because I understand, because if your CPU is hitting constantly like 90%, 95% because of the active sessions and the DB server capacity, like wherever the DB is deployed, and that server is hitting 90% constantly, then obviously you cannot increase your connection pool limit. So along with this CPU, are there any other parameters that we have to take into considerations? Because even when it is a DB connection pool, so it will keep reading from the disk, writing it to your disk. There are a lot of waits happening, the response time going crazy, these kind of things, right? So say for example, I work on Exadata nodes. So each rack cluster will have around a quarter rack cluster has around 125 CPUs. Not virtual CPUs, OCPUs. So combinedly, we have the machine strength is around 250 virtual CPUs. But during the benchmarks, we reach the peak reaches 99%. Okay, with the connection pool set to 1250, we don't see any problem. Okay, but can we increase it more so that the response time is better? How do we know that the response time is bad because of the connection pool only? How can we assess these things?
Do you have a response time of sequels running behind it?
I can get that. There's no problem.
Yeah, if that is not causing any problem, then you don't have any other way other than to increase this pool size.
So you're
But if the
you're
seq
asking me if I know the response time of the sequels that are getting executed during the benchmarks, correct?
sorry,
You're asking me if I know
yes,
the
correct,
response time
yes,
of the SQL queries that
yes,
are getting executed during the
yes,
benchmark.
correct,
But
correct,
there are like
yes.
hundreds of SQLs that gets executed, right? So how
You
we
need
can't
not
sit.
to, yeah, yeah, that is what I was trying to explain in my very first session as well. Need not
Okay.
to go through each and every sequel, okay? Just find out those transactions which you seems to be problematic, which are taking more time. Now, let's say you ran 50 transactions. Out of those 50, the problematic will be only 5 or 6, right?
Okay. Consider this
Yeah.
scenario. Your SQL is getting executed, and there's a uh, 5 seconds response time on that SQL.
Mhm.
Okay. Now, so with that, how do I know whether this SQL can be improved if I increase the connection limit? The CPU, number of executions also matters. The amount of CPU that is used by that SQL query during that benchmark also matters. What kind
Correct.
of waits are happening, that also matters. All these kind blocking sessions also matters. Logs or deadlocks or row logs, these kind of things also matters, right?
Yes.
So now I say 5 seconds is the query, this query is taking 5 seconds. I take a trace, I get to know that okay, this query is taking 5 seconds. But how do I end up analyzing it and figuring that connection pool is the cause here? How do I
Yeah.
do
Uh,
that?
When
Kiran,
so first
what
thing,
I
whether it is a whether it, yeah, please go ahead.
Kiran, what I would do is like I run a test, I generate the AWR report. See, with
Mhm.
connection pool size of 1250,
Right.
everything else is the same, and I'm running a test, and I have the numbers from the test, right? So I will generate an AWR report. It'll show me the top 10 SQLs. You have that information. Then I increase the connection pool size to say 1500, and again run the test. I generate the AWR report. So
No,
just
no, we are not
comparing.
maxing out on the connection pool limit. That is what I'm trying to say. Though we have set the connection pool max capacity as 1250, we are
Mhm.
not utilizing all 1250 connections at that point of time. Okay, I'm not saying we are maxing out on that.
Mm.
Okay, so this whatever
Do you know
1000.
Yeah.
how many connections were utilized out of 1250 from the
When it was
metric?
set to 150, 200, we started seeing these connections getting exhausted. So we increased it
And
to 400, then 600. Then,
see, sorry to interrupt.
yeah, yeah,
Yeah,
go
go
ahead,
ahead,
go
go
ahead.
ahead, go ahead.
So when we perform various tests, okay. So the comfortable number that we came up for the maximum amount of user load of 800 users with a stress test done for 10 hours, right? 1250 we did not exhaust. The maximum it went was around 700 or 800. It kept coming back to the pool. But if it is a issue related to this connection pool limit, and the connection pool limit is also not getting exhausted, does that mean that the issue is not on the connection pool or and I'll have to look into somewhere else? That is how it is? Or is there somewhere I can go look at the SQL trace and then identify that, okay, this is because the connections are not enough during the benchmark, and that is why the response time is so bad, and I'll have to increase the connection limit so that this issue doesn't occur.
I
There's
mean,
no
if
one
the
way.
connection, if the max is set to 200 and the utilization is only 800,
Yeah.
then that may not be the issue. Like increasing the connection pool may not be the
But the race
solution.
conditions, you see, Rajdeep, there is always the free capacity that is available. Okay. Say, for example, uh, when suddenly there is a spike of 100 users coming into the picture, okay, the race condition starts here asking for the connections to the DB, correct?
Correct.
Correct. Now, the response time is sooner for the first few users, and you're getting the response, and the connection goes back to the pool there. Okay. Right. You're reaching 1250, but you're not ending up with the connection pool getting exhausted there. Right. So in that case, then the issue is still not on the connection pool. You're reaching that point, but you're getting back the connections in the pool sooner than you can capture it. Okay. Then is there a way to actually address this problem? I'm not saying this issue is because of the connection pool only, but how do I know it? If it is saying,
Isolate.
like you said, okay, if you're not maxing out, then that is not the connection pool issue. If that is the only thing, then I'm good. Is that the correct way to check is what I wanted to check, ask you people.
In my case, like if I don't see any connection timeout issues, I would not worry about DB connection pool being a bottleneck.
So true. Now you have 1200 connections max capacity. Now you see a connection timeout happening. So how much do you increase? You keep running tests to find out
That's sort of like that's the benchmarking. So if 200 connections I'm seeing an error, I run the same 1 hour test for 400, say
But
300
now again,
connections.
so if you're with the 1200, say for example, with the 1200 max capacity, you started seeing connection timeouts, but your database capacity is also the CPU utilization is also reaching to 99% continuously for 3 hours. Then there's no scope of increasing the connection pool there, right?
Right. Yeah, it's complicated. Yeah.
So I don't know. I've been going rounds on this. Yeah, nice discussion.
Okay, my quick query is
yeah.
Is the business worried about your 5 second of SQL query?
Yeah, we have a SLA. The SLA for the transaction itself is 5 seconds. Now, when the query itself is taking 5 seconds, then it is a problem.
So
now.
that is me. So yeah, yeah. So now you find out the problem. The problem is with your SQL time. Okay. You have
Right.
never seen your yeah. Now how to find that and what to tune that, that is the problem. Correct?
Correct.
So on which tool you are monitoring these SQLs currently?
SQLs, we generate the traces, okay, not during the benchmark. After the benchmark, we generate the traces because you can't enable the trace during the benchmark. It keeps generating a lot of traces because you'll have multiple executions running, right? So the same SQL getting executed multiple times, it will have multiple a trace that is getting generated so huge that you'll max out the storage capacity there. So when we see this problem during the benchmark, we generate a trace after the benchmark for that specific SQL ID. And then we convert that into a readable format using tkprof and open that SQL file and see what is the CPU number of executions, the response time of that SQL query, how many times this was executed, all these kind of things.
Is there any APM connected with DB CPU?
No.
Okay.
Connection time monitoring using WebLogic console. From
Okay.
WebLogic, you
Can,
can monitor the connection pool, and
okay,
it will
because
kind of things. Yeah.
uh in these tools, or I see if somewhere is there any recommendations of given by your web console, or somewhere is there any option to see, because what happen is this APM tool themselves provide some recommendations related to DB indexing. Okay,
Mhm.
so I mean, so I understand you cannot go and check what need to be tuned, but there are by default these APM tools have that capacity to provide some recommendations. If you can get that, that will be helpful.
Currently, what we do is to make it. We don't have access to any APMs,
Mm-hmm.
but what I currently do is I generate a tuning advisor report for that SQL ID. That tuning advisor will actually show me if there is a better plan to pin, if there is a profile that needs to be created, if there is an index that has to be created for this one, if there are statistics that has to be taken on that table, all these kind of things it will recommend. But it will give you like 4 or 5 recommendations. Sometimes that we can't go by that recommendations is because it'll ask you to take, it might be a temporary table, okay, which might get deleted later. Now, the recommendation that it says is, oh, go collect the statistics because there is an increase in the data volume on that table compared to the last page one. But you can't collect that statistics on that table because that is a temporary table, right? So this thing we do, but nothing at the APM level. But
Yep.
we definitely
That
architects and then with them
let's
then
continue
identify
this
this problem.
tomorrow.
Yeah, sure.
Sorry.
A long discussion. Yeah.
Yeah, let's continue tomorrow. Have a great night, everyone. Bye.
Thank you. Thanks.
Vicky may not need to stop the recording, otherwise it'll go on.
You want to have that discussion? Sorry.
I think he said he asked you to stop the recording.
Recording. Okay. Yeah, fine.